Hey there. All right, this one is going to be a little bit longer because I'm going to kind of tie in some application at the end on this one. So it starts off very basic where we use Sohcahtoa as an acronym to help us remember how to set up a sine equation, a cosine equation, and a tangent equation. It's all based on what angle you're dealing with, and it's never the right angle. You have the right angle, but then you have these two acute angles always in a triangle. And so you're basing it off where are you in reference to that. So if you look at number 13, we're looking in reference to angle X here. It says angle X is here. Now the sine is the opposite side over the hypotenuse. If it helps you, you can first right off the bat identify which side is which. So I always start, the hypotenuse is the longest. It's across from the right angle. And then where you put the opposite and adjacent varies depending on which angle you're using. So if I'm using angle X, adjacent means right next to, that'd be 40. Opposite is across, so I'll put an O for opposite and A for adjacent there. Now when they want us to do the sine of it, and it just says find the value of the trig ratio, a ratio is a fraction. So all you have to do on this problem, don't overthink it, you just have to write what is the fraction. So for sine, we want the opposite over the hypotenuse, and then you're done. That's all there is. Okay, let's try again on number 14 here. The cosine of A. So we're basing everything off of angle A. So cosine is supposed to be the adjacent over the hypotenuse. Okay, adjacent means next to. Now, yes, there are two angles that are next to it. There's a 50 and a 30. But notice that the 50 is actually the hypotenuse, though. So the adjacent would be 30 over hypotenuse 50. 30 over 50. Be sure that you always reduce your fractions if you can. In this case, the 30 and the 50 would reduce to 3/5. All right, let's see if you can do some of these. Let's go to, I'm just writing the trig ratio. You do on number 15, can you do tangent of Z? All right, from angle Z, tangent is opposite, that'd be 9, over adjacent, that'd be 12. You'd have 9 over 12, but you should reduce your 9 over 12 to a 3/4. All right, now try Z, or cosine Z. All right, cosine is adjacent over hypotenuse. Looking at this triangle, the 37 is your hypotenuse, the 35 is the adjacent. You should have 35 over 37. Once you have the ratio, can figure out how to set that ratio up. Let's do some little equations to actually solve, because that's ultimately our goal. Oh, this is an extra slide. I think we got that. It's going to be long enough as it is. Okay, so on this one, we're going to set up a sine, cosine, or tangent equation. You absolutely, positively have to have a calculator for this. It's not mental math. You can't do this without a calculator. You have special buttons on your calculator you have to be able to use. So I'm going to use the angle they gave me, the 42. And then I'm going to pay attention to what other two sides we're dealing with. Well, it looks like they gave us the hypotenuse. So I'm going to do the hypotenuse, and then I'm looking for what appears to be the opposite. So I come up here and say, okay, opposite and hypotenuse, that would be sine, opposite over hypotenuse. So then let's set up our equation. The sine of that 42. It's always the sine or the cosine or tangent of your angle. Sine of 42 is equal to the opposite over the hypotenuse. Now you just do a little bit of algebra to solve your equation. Take both sides times 19. So the 19s cancel. And then in your calculator, you're just going to type 19 times the sine of 42. And you get x to equal 12.7. All right, now you have to be careful with your, if you hit sine and it opens a parenthesis, be careful with closing your parentheses and stuff. Okay, let's try this again. Number 18, we've got to figure out from this 61-degree angle, which two sides are we dealing with? The x is opposite. I always can pinpoint the opposite is straight across. And the 17 is right next to it. That's adjacent. So I come up here, opposite and adjacent, that's tangent. So I'm going to set up a tangent equation. Tangent of your angle is equal to opposite over adjacent. Okay, type that, solve that, and then type that in your calculator. Tell me what you get for x. All right, you should have multiplied both sides by 17. And in your calculator then, 17 times the tangent of 61 is 30.6. Oh, actually 30.7, because it rounds. All right, let's keep practicing. All right, I'm going to do one more, and then you're going to do one more. So here we go. Number 17, I'm looking at from the 19-degree angle right here. The 11 is your longest side. It's across from that right angle, so there's your hypotenuse. And then x is next to it, so that's adjacent. I've got hypotenuse and adjacent. That's this one, cosine. Cosine is adjacent over adjacent over hypotenuse. Cosine of 19 is equal to adjacent over hypotenuse. I'm going to take both sides times 11. You tell me what you get. I got a 10 point, oops, that's not very neat. 10.4 for your other side length. Okay, I'm going to let you set 18 up by yourself. Tell me what you get for x. All right, what you should have done on this, from the 48, you've got opposite and adjacent. That's a tangent scenario. Tangent 48 equals x over 10. Hopefully that's what you had. You're going to multiply both sides by 10, and then you're going to end up at x equaling 11.1. Hopefully that's what you got. Okay, so now we're going to do something that's a little bit different. We're going to look for the angle this time. So if you have to look for the angle, that's when you use the second button on your calculator. So right here, first you got to decide if you're going to do sine, cosine, or tangent. So it looks like I've got opposite and adjacent. Opposite and adjacent, that's tangent. But here's the thing, is it's a little bit different because, all right, tangent of x. I'm looking for the angle. I don't know the angle. I already know the opposite and the adjacent. When you're looking for the angle and you're trying to isolate the x, you have to get rid of tangent. To get rid of tangent, you do second tangent or inverse tangent. So in my calculator, I just type second tangent, and then I do that fraction, 45 divided by 47. I end up at a 43.8 for your x. Okay, so let's look at this next one. I'm looking for the angle again. So from that angle, I'm trying to decide which sides I'm dealing with. Let's see, there's your right angle, so there's your hypotenuse, that's one of the sides, and 30 is opposite of the angle. So I've got opposite and I've got a hypotenuse. That's sine. So I'm going to do sine of my angle, I don't know what my angle is equal to opposite over hypotenuse. Okay, you go figure out, what does x equal? All right, hopefully you got, that rounds off to, nope, it does not round off. 69.6 is that angle measurement. Okay, so these two are for you to do all by yourself. Can you set it up and then tell me what the angle is? So let's start with number 21. Set up your trig equation and solve. All right, on this one, you're dealing with the adjacent and the hypotenuse. That's a cosine problem. So cosine of x is equal to adjacent over hypotenuse. You type in your calculator, second cosine, and then that fraction. And the angle that you should have gotten for this was 25.5. All right, let's do 22. Okay, just to mix it up on 22, because they do vary sometimes in what they have you round to. So let's say on 22 that, oh, look, I was not even reading the directions. No, that's not good. It says round it to the nearest degree, and I'm sitting here rounding it to the 10th. So in 22, let's round it off totally to the nearest degree. All right, go find that angle measurement. Okay, this is a sine scenario. Sine of x is equal to the opposite over the hypotenuse. So when you do your second sine, and again, always doing second sine when you're looking for your angle, I got a 33.6, so I'm going to say x is 34 degrees. Okay, let's try something else. I want to kind of use these problems in some of the reason that this is so important is because we keep using it in other types of problems. And I thought I'd do this. This is a chapter 10 question right here. I'm throwing this in. If you haven't done chapter 10, this may not make sense to you yet, but the idea is that we're going to find the area of this pentagon. And the area formula for a pentagon is 1/2 the apothem times the perimeter. And the way that we work through this, if this was a hexagon or an equilateral triangle or a square, it creates these special right triangles in here. When you draw in all these they're called radii, to the vertices of your pentagon, this would create a special right triangle at some point. Okay, on a pentagon it does not, because if you take 360 and divide it by 5, you get a 72-degree angle. So then the next step, what we do when we're finding that area, is we drop what we call the apothem. The apothem comes straight down from the center, perpendicular. So what do you think happens to that 72 degrees? It gets cut in half. So now we have an angle measurement that is 36 degrees, and that would not be a special right triangle. Now what I just found right there was, or what I drew was the apothem. Let's call that A for the apothem. And that's what you need for your formula. But you also need the perimeter. And to find the perimeter, we're going to actually identify or figure out what this length is. So look at your triangle right here. This is the triangle that gets created. And so let's do some Sohcahtoa to see if we can figure out. I'll put this as x over here. So from that 36, it looks like you got opposite and you've got adjacent that you're dealing with. This is a tangent problem. So I'm going to do tangent of 36 is equal to x. Oh, sorry. How about if I give you a number? Sorry, that might help. Okay. Let me get rid of this x. Let's say you know that. Let's say you already know that side measurement. Actually, let's make life even easier. What if I told you that the perimeter, and they would give you information on this. Let's say that they told you that the perimeter was 20. Okay, so think about what that means. Let's break that down. The distance all the way around is 20, which means each side would have to be 4. And then when you look at this scenario, if the whole side is 4, then this little piece right here would be 2. All right, so by them telling me the perimeter, they really told me that that little leg there is 2. So now let's do tangent. Tangent of 36 is equal to opposite over adjacent, 2 over a. Okay, now this is a little bit different problem than we had earlier. I wanted to have something like this happen to us where the variable that you want is actually in your denominator. So when you try to get rid of this fraction, you're actually going to multiply by a. Multiply by a. That's what we do if the variable is in the denominator. So then you're left with a times the tangent of 36 equals 2. So if I'm solving for a, I'm going to have to divide by that tangent of 36. Sometimes we multiply, sometimes we divide. So here's a scenario where I'm going to type in my calculator. It's 2 divided by tangent of 36. These take just a little bit more work when that variable is in the denominator on your Sohcahtoa. All right, so I got a to equal 2.75. So then what I would do is I'd go back to my area formula that we have. Area equals 1/2 the apothem, that's what I just found, 2.75, times the perimeter, 20. And I would multiply that out. I guess I'll go ahead and finish it. 0.5 times 2.75 times 20. All right, I got the area to equal 27.5. Okay, so this is a pentagon. On a pentagon, you end up having to do some Sohcahtoa. You'll have to do Sohcahtoa on an octagon, a decagon, and so that's part of chapter 10. That's where we use this Sohcahtoa. Okay, let's do an angle of elevation, or an angle of depression type of problem. All right, when you're doing angle of elevation or angle of depression, you have a scenario where you're looking, we're going to start with an angle of elevation. You have a scenario where you are looking up at something. So you can see this little girl is looking up at this kid that's at the top of the Eiffel Tower, standing on the very tippy top. Okay, so you have to imagine this right triangle that gets created from this. Now, probably in this question, they want to know, hey, how tall is the Eiffel Tower? So I'll put a big X over there. How tall is the Eiffel Tower? And we're going to ignore this. My triangle isn't perfect there. It doesn't really hit the bottom of the Eiffel Tower. We won't overthink it. Okay, so then what probably is going to happen is they're going to tell you how far back she is from the Eiffel Tower. Let's say that she is 50 yards back from the Eiffel Tower. And then they do have devices that measure angle of elevation. So let's say for some reason she happens to know that this angle of elevation is 63 degrees. I'm totally making that up. Okay, so what you have though is you've created this right triangle. Okay, so look at that. You're going to use your 63 degrees. Do you think this is going to be a sine, cosine, or tangent problem? All right, hopefully you said tangent. So I'm going to do opposite over adjacent. I'm going to set it up. Tangent of 63 is equal to opposite over adjacent. Okay, we got lucky. Our denominator is a number this time, so you get to just multiply by the 50. Go ahead and tell me, how tall do you think the Eiffel Tower is? All right, you should have typed in your calculator 50 times the tangent of 63. The Eiffel Tower is 98.1 yards tall. Maybe. I don't know. Okay. All right. One last problem. Let's do an angle of depression. Angle of depression is a little bit sneakier because typically the angle of depression is not really part of your right triangle. So here you have a scenario, some guy standing on top of a brick wall looking down at this car. And the angle of depression, they tell us, is 30. The problem is, okay, typically what you're looking for is maybe how tall is the brick wall, if we know that the car is 40 meters out there. So the triangle that I see when I do this is this one right here. I see this triangle happening. But they told you that the angle of depression is 30 degrees. That's not really part of the triangle. So what they've done in this picture, they put it down here also, because look, those are alternate interior angles. So if this angle of depression is 30, this angle down here at the bottom would also be 30. So that would be one way to do this problem. There's two ways. I'm going to show you two ways, and you pick whatever you think you're going to remember and makes most sense to you. So if you do the alternate interior angles and they tell you this, what your angle of depression is, and then you immediately go write it down in this bottom corner. Now let's look at what you have. You have a tangent problem, because you know the adjacent, but you're looking for the opposite. So here's what I would set up. I'd say tangent of 30 is equal to the opposite over the adjacent. Okay, go find X for me. How tall is the brick wall? All right. It should be 23.1 meters. Okay, here's a different scenario. And again, I don't care which way you do this. I want you to do whatever makes sense and you're going to remember how to do. Okay, so now I'm going to change it up and I'm going to do a different triangle. Well, I'm sorry, I'm not going to do a different triangle. It's the same triangle. But another way to look at this is to say, well, if this angle up here is 30, and you know that this will always create a right angle, if that one's 30, this has got to be its complement. So this one would be 60. Those always have to add up to 90, that angle of depression and the angle that's in the triangle right there next to it. Those are complementary. So if you just subtract from 90, oh, okay. So now I have this 60-degree angle. Let's pretend we didn't do this 30 thing down here. You still have tangent. Opposite is 40, adjacent is X. So tangent of 60 degrees is equal to the opposite over the adjacent. Okay, now when you do this problem and set this up, I have a different angle and my fraction gets flipped. Let's see what happens. On this is one of those tougher ones where you have to multiply by the denominator. So I'm going to multiply by the x here. So then I have x times the tangent of 60 equals 40. And so this is the one where I come back and I divide by tangent of 60. Divide by tangent of 60. Okay, go find x for me. All right, 40 divided by tangent of 60 actually ends up being 23.1 also. You should get the same answer both ways. You pick which way you like the best. All right, that's all I've got for you. Thanks for joining.